the sheet again, as we have already discussed that this chapter is p block elements. P block elements means the outermost electron will goes to the p orbitals, and thus this group, that is p blocks or p subcells, have 6 electrons. So they will have the 6 groups, that is group 13 to group 18. The outermost electronic configuration of that group is ns2 np1 to 6, and the properties depends on their atomic size, electron gain enthalpy, ionization enthalpy, and electronegativity. Here we will discuss from group 15 elements. Group 15 elements. As group 13 and 14 is in class 11. Now, group 15 elements include nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium. As we move down the group, there is a shift from non-metal to metallic, and then in between that non-metal to metal we have metalloids. This is because of gradual increase of size. If size increase, then the capacity to lose electron gradually increases due to the lowering of force of attractions among themselves. As size is smaller, then whenever we put electrons, then electron can easily enter to the orbital, so they become electronegative. That is why the first members of each group are of non-metal. When we move down, gradually size increase. Size increase means force of attraction between the nucleus and the other electrons gradually decreases, and hence it runs from non-metal to metalloid and then metallic properties. That means higher members of each group are of metallic in nature. So nitrogen and phosphorus, in this group 15, nitrogen and phosphorus are of non-metals. Arsenic and antimony are of metalloids, whereas bismuth and moscovium are of metallic type. Now let us see about the occurrence. More molecular nitrogens, which is 78% by volume of the atmosphere. That means in atmospheric air we get nitrogen at the amount of 78%. And in the earth crust it occurs sodium nitrate, that is Chile saltpeter, and potassium nitrate. It is found in the form of protein in plants and animals also. Phosphorus occurs in the form of minerals in the apatite family, that is calcium phosphate and calcium halides, like calcium chloride, that is having the formula CaX2, that is about the calcium halide, and calcium phosphate, it is the formula Ca9EO4 6 times. Ca9EO4 6 times. Ca9EO4 6 times. This is calcium phosphate. Like this one we get. Phosphorus is an essential constituent for animals and plants material, as it is present in bone and all the living cells. Phosphorus are present even in milk as well as egg. Arsenic, antimony, bismuth are found mostly in the sulfide minerals. Moscovium is a synthetic radioactive element. Now, due to the very small half-life period for moscovium, the ability of these elements is very small. Except moscovium, important atomic and physical properties of other elements of this group along with their electronic configurations are in the table 7.1, which we will not discuss. You can see the table, and from that you can get atomic number, atomic mass, electronic configuration, ionization enthalpy, then electronegativity, then covalent radius, ionic radius, melting point, boiling point, density, you will get easily. Now, let us see about the physical and chemical properties of these elements. First, let us go to the electronic configuration. Now, the valence and electronic configuration of this group, that is group 15, is of NS2 NP3. That means group 15 elements have the outermost electronic configuration NS2 NP3. Now, the s orbital in these elements is completely filled, that is NS2, and the p orbitals are of half filled, as p need to have 6 electrons to make it stable, but here we have 3. 3 means half filled. Half filled orbitals are also stable. Now we'll go to the atomic and the ionic radii. Covalent and ionic radii. In a particular state, radii increases in size down the group. That means covalent and ionic radii increases down the group. There is a considerable increase in covalent radius from nitrogen to phosphorus. From nitrogen to phosphorus, there is a considerable amount of increase of their atomic or ionic radii. However, from AS to Bi, bismuth, arsenic to bismuth, only a small increase is there in the covalent radii. This is due to the presence of completely filled or completely filled d orbitals or f orbital. Due to the presence of completely filled d or f orbital, the repulsive force starts in between the core electrons and outermost electron. This repulsion of outermost electrons make them the small increase of size. So we can ask why the size of arsenic to bismuth have a small increase in the covalent radii as compared to the group elements in the same group which is in the earlier members. Then lighter members. Lighter members have gradual increase in size, whereas heavier members have a small increase in size. Why? This is the question. Your answer is due to the presence of completely filled d and f orbital in the particular shell, the force of attraction gradually decreases due to the electron-electron repulsion among the incoming among the valence electron and the core electrons, which make the decrease in the size smaller. Now we'll go to the ionization enthalpy. Ionization enthalpy decreases down the group due to the gradual increase in atomic size. That means if atomic size increase, then ionization enthalpy gradually decrease. Why it is decrease? Now, if atomic size is smaller for the lighter members we know that the atomic size is smaller. If atomic size is smaller, then the force of attraction between the outermost electron and the nucleus is very high. So in order to remove electrons from that high force of attraction, we require higher energy. Due to that, the lower members have higher ionization enthalpy. As we know that ionization enthalpy is the energy required to remove one electron from its stable electronic configurations. If we move down the group, size gradually increases, thereby the force of attraction gradually decreases. So to remove electron is easier. Due to that, due to the increase of size, the ionization enthalpy gradually decreases down the group. Again, because of extra stable half-filled p orbitals electronic configuration and smaller size, the decrease in this ionization enthalpy gradually decreases while increasing the size. This is also another factors. Now, let us compare the ionization enthalpy. The ionization enthalpy of group 15 elements is much greater than group 14 elements in the corresponding period. The order of successive ionization enthalpy is expected from the first ionization enthalpy is less than second ionization enthalpy, which is less than third ionization enthalpy. Here what we know is that first ionization enthalpy means first electron removed during the time how much energy is required, that is what we call as a first ionization enthalpy. And if electron is removed, then the species become positive charge. So already force of attraction is gradually higher. So from that higher force of attraction, if you want to remove second electron, automatically the energy required is more. If you remove third electron, then it requires more energy as the force of attraction is higher. That is why delta IS1 is less than delta IS2, that is less than delta IS3. This is what in case of ionization enthalpy. Now we'll go to the electronegativity. Electronegativity value in general decrease down the group. Electronegativity value in general decrease down the group with increase in the atomic size. This is because electronegativity means the power of attracting electrons that we call as a electronegativity. Here, if size increase, down the group means automatically size increase. Due to the increase of the size, the force of attractions between the nucleus and the outermost electrons gradually decreases, and hence the power for attracting electron gradually decreases. This is the reason for why electronegativity decreases down the group while increase in the atomic size. However, among the heavier elements, the difference is not that much pronounced. This is because of the core electrons, that is D and F orbital, presence of D and F orbitals, which make shielding effect. Due to the shielding effect, the decrease of electronegativity is not much differences when we move down the group in the heavier elements. Now we will go to the physical properties. All the elements in this group are of polyatomic. Dinitrogen is of diatomic gases, while the others are solid. Metallic character increases down the group, and nitrogen and phosphorus are non-metal. Arsenic and antimony are metalloid. Bismuth is metal. This is due to the decrease in ionization enthalpy and increase in atomic size. The boiling point in general increase from top to the bottom in the group, but melting point increases from arsenic. Melting point increases up to arsenic and then decrease up to bismuth. Except nitrogen, all the elements shows electropy. That means group 15 elements almost shows electropy except nitrogen. As you know already what is electropy. Electropy means the capability to exist in different forms of an element that we call as electropy. Which in your class 11 you have discussed about the electrons of carbon, that is graphite and the diamond. The common oxidation state of these elements are of -3, +3 and +5. That means these elements can show variable oxidation state, and the tendency to exhibit -3 oxidation state decrease down the group. This is due to increase in the size and metallic characters. So we can ask, what is the tendency of exhibiting -3 oxidation state among the group 15 elements? Say your answer is the tendency to exhibit -3 oxidation state decrease down the group. This is due to the increase in size and metallic characters. The stability of +5 oxidation state decrease down the group. The stability of +5 oxidation state decreases and that of plus 3 oxidation state increase down the group. This is due to the inert pair effect. Inert pair effect means those capability of an element to show oxidation state differ by plus 2. As we know that here plus 3 to plus 5, that means plus 2 difference is there. This is what we call as a inert pair effect. Besides plus 5 oxidation state, nitrogen also exhibit plus 1, plus 2, plus 4 oxidation state also. When it reacts with oxygen, that means the different oxidation state except plus 5 can be shown by the compounds of nitrogen with oxygen, by the compound of nitrogen with oxygen. However, it does not form compounds in plus 5 oxidation state with halogen, as nitrogen did not have d orbitals to accommodate electrons from other element to form bonds. So we can ask why nitrogen does not form pentahalides. Your answer is due to the absence of d orbitals in nitrogen. Nitrogen does not form pentahalides. So phosphorus can exhibit plus 1 and plus 4 oxidation state in some oxo acids. In case of nitrogen, all oxidation state, that is plus 1 to plus 4, tends to disproportionate in acidic solution. What do you mean by disproportionation reaction? Disproportionation reaction means any reaction in which one species can undergo both oxidation and reduction. That is what we call as a disproportionation reaction, or we can say increase and decrease of oxidation state taking place in one species. That is what we call as a disproportionation reaction. Now let us see disproportionation reactions of nitrogen, that is 3 times of ice NO2. 3 times of ice NO2 gives ice NO3 plus water plus 2 times of NO. This is the disproportionation reaction of nitrogen. Similarly, in case of phosphorus, nearly all intermediate oxidation state disproportionate into plus 5 and minus 3, both in alkali as well as acidic state. Whereas in case of nitrogen, only in case of acidic solution will undergo disproportionation reaction. But in case of phosphorus, it can undergo disproportionation reaction both in alkali as well as acidic solution. However, plus 3 oxidation state in case of arsenic, antimony, bismuth becomes increasingly stable with respect to disproportionation. Nitrogen is restricted to a maximum covalency of 4. That means the maximum covalency for nitrogen is 4. Since only 4, that is what, 1 from S and 3 from P can undergo bonding. The heavier elements have vacant d orbitals. The heavier elements have vacant d orbitals in the outermost shells, which can be used for bonding, that means for covalency. Thus, the covalency expand up to 6. So we can ask here one question. LF6 cannot exist, but BF6 can exist. Why? Although they are in the same group. So your answer is nitrogen can have covalency up to 4 only, whereas B have d orbitals. Due to that, their covalency can expand more than 6. That is why we have PF6 minus in the nature, whereas NF6 is not available in nature. Now let us see about the anomalous properties of nitrogen in the next video. Thank you.